Hello, everyone. Today we are going to be talking about addition reactions. Addition reactions are characterized by adding two groups across an alkene. For today's video, I'm going to be talking about and showing you guys an Markovnikov addition and an anti-Markovnikov addition. So we're going to start with the anti-Markovnikov addition, and that is the hydrobromination reaction. And like I said earlier, it's an anti-Markovnikov addition, which means that the H is going to go on the more substituted carbon, and the bromine is going to attach at the less substituted carbon. This reaction takes place best in the presence of bromine, hydrobromine, and peroxides. So that's what makes it different from the hydrogen halide addition reactions. It does include a hydrogen, it does include a halide, but this particular reaction works best with bromine and peroxides. So to understand the reaction and how to correctly predict your products, it's important to understand the mechanism of this reaction. This reaction, since it is a mechanism involving radical intermediates, it is said to be self-propagating. So it's a reaction that can kind of go on and on and on. And I got this mechanism from the book Organic Chemistry as a Second Language, the first semester, and it helped to break it down fairly easily. So what happens is peroxide bonds are easily broken in the presence of light. And when these bonds break, it yields these two products. And these products are radicals. And what happens is these radicals are then able to abstract a hydrogen from the HBr, leaving behind an alcohol and a bromine radical. The bromine radical can then attack the alkene, and it adds itself to the less substituted carbon, and it forms a tertiary radical. And what happens right here, another HBr molecule is in solution, and the carbon right here attacks the hydrogen, and the radical is no longer. So it's a bit of a complicated mechanism, but this right here, what I wrote down and what I explained, is pretty much the gist of it and pretty much what you need to understand for this particular semester or session of organic chemistry. Next, I wrote down a simple problem, which I just drew the products because I drew the mechanism first. So as you can see, the bromine is attached at the less substituted carbon, and the hydrogen is attached at the more substituted carbon. Just a quick little break. Sorry. Now we're done. We're done with the hydrobromination reaction. Please excuse that small disturbance. Next, we're moving on to the Markovnikov reaction, which is the hydrogen halide addition. And this too has a mechanism that is important to understand. It has two parts, a proton transfer and a nucleophilic attack, which we are familiar with from doing SN1 and SN2. And the hydrogen is added to the less substituted carbon, and the halide is added to the more substituted carbon. So this one is fairly simpler than the last reaction that I showed you all. So what happens is the alkene attacks the hydrogen, leaving behind a chloride ion, and the chloride ion attaches itself at the more substituted carbon, and the hydrogen atom attaches itself at the less substituted carbon. Of course, we can't see that because hydrogen atoms are not shown in bond line drawings, but it's understood that the hydrogen was attached at the less substituted carbon. So this one does not involve radical intermediates. It's just a simple proton transfer, and a nucleophilic attack is what drives this reaction. This one is, again, a Markov-Markov addition, so it's very important that you attach the halide to the more substituted carbon. And again, I hope that these overviews helped. But I really just wanted to point you in the right direction of just really understanding what's going on. I do recommend using organic chemistry as a second language. It's really helpful with putting the reactions and topics of organic chemistry in plain terms. I hope that was helpful, and thank you all, and good luck on the final.